to learn some things about Lightning Web Components. Yay! It's so exciting. Did anyone go to Wes Nolte's talk this morning? Yeah, it was really good. I enjoyed it. I enjoyed the fact that a lot of the things that Wes was suggesting and talking about, there's actually a good deal of overlap. So when he was talking about best practices like using linters and getting your head around how promises work and using modern parts of the JavaScript language, the great thing about that is those are all lessons that you can take and move forward with even as we launch this new programming model for the Lightning framework. So there we go. My name is Peter Chittum. I don't think I've said that yet. I lead the developer relations team in EMEA. I'm also a developer evangelist, part-time these days. So I still get to come out and give some of these talks and write some code now and again. My Twitter information is up there. So is my email address. I welcome any and all tweets, emails, or whatever. It's one of the great things about being in developer relations is you, actually. I look forward to coming out here in the community and seeing people and getting your feedback and hearing what's working and what's not, and then taking that back to the product to hopefully make a better product for all of us. Before I say anything else, I may make some forward-looking statements, and just don't make any purchasing decisions based on anything I talk about that is not generally available in the product today. My plan today is to go through kind of 4 things. First of all, I'm going to revisit the introduction to Lightning Web Components. I think it's a new enough feature in Salesforce that it's worth doing that. How many people made it to one of the developer groups where we came out and talked about Lightning Web Components in person back in January and February? Not that many. OK, so that won't be too much repetition. Has anyone seen any of our webinars that we've put forward? OK, a few more people. Has anyone done any of the Trailhead Trail for Lightning Web Components? Even more people. Wow, that's cool. We have better uptake on the Trailhead stuff than we do in our webinar. Or how about, yeah, so that's cool. So we'll do the introduction. I actually was practicing this last night, and I hated my talk. And so I've been kind of rethinking how I tell the story of what I want to do, and kind of switching some things around on my slides all day today, and kind of fiddling and tinkering. And I like a little bit better how it's come out. So I want to talk about specifically when we were launching Lightning Web Components, and we got to find out a little bit before you all did. And I set myself a goal. I wanted to do something that was fairly granular. In other words, it kind of fit the component story. That was relatively challenging and complex. And then also exercised a good amount of the surface area of what you need to know in a Lightning Web Component. And so what I built, because I live here in the UK, was a UK postcode lookup component. It's actually a really great use case. You make a call out to a web service. You need to update some stuff in Salesforce. There's a little bit of DOM repainting and refreshing that has to go on as part of that. And there's also some passing of data using events between components in the same tree. So it fits a lot of little bits and pieces and nuggets that have to do with composing a Lightning component and architecting a Lightning component. So that's what I built. And as part of that, I want to talk about how I went about learning the different pieces that I had to learn of the Lightning Web Component programming model so that I could accomplish all of these things. And I'll show you where I found that in our sample app gallery. Then what I'll do is I'll take those same things and I'll show you how I then applied them to this sort of end-to-end component story. Sound good? That's my plan. All right, cool. So a little bit about Lightning Web Components. This was conceived some time ago, about 18 months before we launched it, possibly even longer. And there were some really important founding principles of the Lightning component framework. One is we wanted it to be very much standards-based, to look and feel like typical JavaScript, so that it could really enhance the productivity of our developers, so that they didn't feel like they were learning something proprietary. They were learning something that would work anywhere. We wanted to be very performant, and by aligning ourselves with standards that were being adopted in browsers, it's actually relatively easy to do that, in fact. There are some choices you can make as a developer that can improve or reduce the performance of your components, and I'll talk about that a little bit later. But fundamentally, if you're building to the spec that the browser supports, that means less JavaScript to shim or to polyfill the functionality that you need, and so your components should be faster. And then finally, we wanted it to be compatible with our existing framework. So we didn't want to launch a whole new framework. We just wanted it to be easier to develop the components on the framework. And so that's why we call Lightning Web Components a development model as opposed to a whole new framework. Underneath the covers, the Lightning framework is still there. We're still using a lot of the infrastructure that was there, like Lightning Data Service and Locker. You all love Locker. And several of the other pieces of the core Lightning framework. But what's different is how you actually compose that user interface or build that user interface. To kind of go back in history, the story of Aura really kind of models the story of a lot of client-side frameworks of the day in 2014. In 2014, the web standards were very thin. They covered basic things, certainly basic JavaScript syntax, but then there were also events, standard elements, and there was a rendering engine. But anything above and beyond that, you were forced to build yourself, and that meant, of course, writing something in JavaScript. And so this was the era of a new framework every day. And how many people have built, sort of in this era, web applications using more than one framework? Not single applications, but in the process of doing your job, you've had to use maybe Backbone and Angular or Vue or React or whatever. It was kind of that time where everybody was coming up with a way to sort of reinvent how to do a web framework. And that's fine. I mean, that's what we had to do. But it had some side effects. Certainly, one of the main side effects is that you found that it was hard to find resources because you had to find an Angular developer as opposed to a JavaScript developer. Sometimes you learned the framework, not the language. There were so many frameworks, as we've already talked about. And of course, as we've said, if you're going to build a bunch of abstractions in JavaScript on top of the browser, that's going to be slower than actually just using the browser itself, right? Now, since that time, we've had this proliferation and really explosion of web standards that have not only just been produced and adopted, but also been implemented in the browsers. And so what that means is that there's more stuff in the browsers to actually use to support our web applications. And we kind of have a list of a bunch of things over there that have come to bear in the past couple of years. I remember actually going to it was an Angular meetup, I think in about 2015, and ES6 hadn't actually gone live yet. But some of the things that they were showing, especially things around like syntactic sugar, certainly things around like using promises, classes, that sort of thing, were looking really, really exciting. But we couldn't really use it at the time unless you were writing it in ES6 and then transpiling it with something like Tracer or Babel or whatever, right? So now that all of these standards have been adopted by the browser, what we have is a story that looks more like this, where the web standards are actually very rich. And the capabilities of the browser that support those web standards have grown tremendously. And so if I need a framework today, the number of things I have to implement in my framework has reduced significantly. And essentially, if there's any specialized service that your framework needs to do, if there's any specialized data services, or if there are any specific components that you want to build to support your framework, those are things that you're going to have to implement. But apart from that, a lot of the other things that we used to have to build in the framework itself, those are all supported by the browser. So things like custom components, templating, custom elements, modules are supported. So it's actually a much richer landscape out there. And this is really the landscape that the Lightning Web Component team was looking at as they were conceiving of what would the next generation of custom user interfaces look like in the world of Salesforce. Now, not all of these were implemented at the time. However, the standards existed to the degree that they could look at the standards and say, that is our North Star. We want to be where the standards are. And in fact, the story of Salesforce and the Lightning Web Component team is beyond just we want to be where the standards are, because you may have seen the announcement recently. Salesforce actually joined and is now an active participating member in ECMA. So we're not just listening to the standards and following them, we're actually helping to shape them going forward, which is a great thing for all of us. And that's really what Lightning Web Components looks like. So we have our web standards. We're using this to the greatest degree possible. And when I say that, I'll bring up a specific example. Shadow DOM is a way of compartmentalizing functionality at a particular level in the DOM tree. It is not 100% adopted across all browsers as of now. And so as of today, when you use Lightning Web Components, you're using our synthetic Shadow DOM. There are also some limitations that Shadow DOM has as well around testability that haven't been overcome right now. So, while we try and aim always for the standard, we're also willing to create what we absolutely have to when necessary. But for the most part, I mean, if you look at custom elements, you don't actually invoke the custom element API yourself exactly, but when you build a Lightning Web Component, that's what's being done on your behalf, in fact. All right, but the core of the Lightning Web Component framework is first and foremost security. Trust is our #1 value. I'm sure you've heard before at Salesforce. And of course, that has to be the case, especially in your front end. So locker service is, of course, still a key part of the Lightning Component framework. Lightning Data Service still exists. It's been expanded, and there are additional features that have been used to incorporate and make use of the user interface API. Who here is familiar with the UI API? Okay, that's homework for everybody here. The UI API is a really cool iteration on our REST API that is architected in a way that is specifically for building front-end applications. So it makes some of the things that are perhaps a little bit clunky when you're using the REST API directly, it actually surfaces a lot of those features in a much more straightforward way if you're building user interfaces. And then finally, we have some base Lightning components, which actually are the same base Lightning components you've been using for the last year and a half, because at that time, we made a decision that we would start to implement all of our new base components in what would become the Lightning Web Component programming model. So what's nice is that anything that begins in the Lightning namespace, it may have been around for a year and a half, but that was built using the same programming model and the same set of libraries that you're using today, fundamentally, for Lightning Web Components. So in that sense, we've been actually testing and vetting and giving the Lightning Web Component architecture a workout over the last year and a half, and you've all have helped us do that as you've built Lightning Aura components. Okay. So I think I've covered a lot of these. Standards are good, less proprietary also good. Using a common component model also good, makes skills more transferable, easier to find developers, and of course better performance. The last thing I'll mention here is around interoperability. You can actually have Lightning Web Components and Aura components all working together. The only real limitation is that you cannot insert an Aura component into the DOM of a Lightning Web Component. That will not work. Whether you do it through markup or dynamically, it's not going to fly. So just be aware of that. You can certainly put a Lightning Web Component in an Aura component, because you've been doing that for the last year and a half anyway without knowing it. All right. And I think that pretty much, yeah. So what I wanted to do, as I said, is kind of look at this example component. I'll show you a little demo. I've got a little architecture diagram that I drew of how this component works. And as I said, it's a UK postcode lookup. And for those of you at home, because I know we're broadcasting this live, UK postcodes are highly predictive of a small number of addresses. It's a little bit different from the way a lot of postcodes work in a lot of other countries. So a single postcode can have from 1 to maybe 50, 80, but a pretty small number of postcodes. So the usual flow when you talk to somebody on the phone who wants your address is they don't ask you for your street number, they ask you for your postcode, and then their software will often help them find the actual house number or house name of where your residence is or where your place of work or such as it is. So yeah, so it's very different. And the nice thing is that I'd never seen anyone build this before. So this is what it looks like. I'm in an account, and I'm going to show the details here because we're going to be making a change to the address, not directly, but by going over here and using this address lookup component. So address lookup, we type in a postcode. This is a postcode for John O'Groats. It's a long way from here. Any Scots in the room? No? Okay. We need a Scotland dreaming, don't we? So I found my address. I select that, click save, and down here you can see it updates. And the nice thing is that the amount of code to make that update happen where this is standard user interface, this is custom user interface, is super minimal because of the fact we're using Lightning data service. So there's a synchronization that happens. So the way this looks like here, and the colors actually mean something, but I'll come back to that. There's my MK360S, a little trivia, that's Bletchley Park's postcode. I do a fetch. This is just a straight JavaScript fetch API call. So I'm going from the component, not using an Apex proxy, directly to my REST service, okay? I get back some addresses. That populates a subcomponent. I then select one of those. That's going to fire an event that populates a value in the parent called selected address. I've got a record ID because this is a component sitting on a record homepage. And so with my record ID, my selected address, I use a wire service adapter. That's one of those things that surfaces the UI API to go and do an update to my account. There's a little bit of Apex in this story, and I'll show you where that is when I get to going through the code of this component. But it's not obvious from this. Now, as I was sort of plotting out what I wanted to do, what was great is that we had all of these sample apps. Who here has played around with any of the sample apps so far? Okay, so yeah, about 15 or so people, certainly a minority of the audience. Hopefully I can convince you, all of you, to give it a try today because I found it extremely effective as a way to think to myself, okay, I need to, whatever it is, make a call to Apex, save some data, and I was able to go into the sample apps to find examples of these things. So for instance, LWC recipes, 90% of what I'm going to show you came out of that particular sample app. And the recipes are all meant to be small little snippets, fully functioning, of 60 lines of code or less. That's kind of the rough benchmark that we go for these. And they're all meant to solve like a single problem, like how do I invoke Apex? How do I implicitly invoke Apex? How do I have an editable form? How do I base that on the metadata of that form? So like all of these things are meant to be very granular so that you can sort of understand how to solve one problem and then kind of like I did, eventually sort of weave all of those together into solving your overall problem. The actual sample gallery is in Trailhead, although there's no link for it yet. But if you go to trailhead.salesforce.com/sample gallery, you will find that. If you want to see the code, it is in github.com/trailheadapps. So that's the URL down there. Although if you're in the sample gallery, every one of these has a link to the GitHub repo for that particular solution. And there's 5 of them today. I used code from 2 different ones, mostly from recipes and one from one called Dream Invest, which is meant to be sort of a financial services use case. So let's go through, and I'm going to show you a bunch of things that I was looking at to make this whole component work. I'll talk a little bit about binding. Decorators are a bit of syntactic sugar on a way to invoke a function in multiple different classes, or I should say multiple different modules, without having to individually implement them in a JavaScript class. I'll show you how to invoke some Apex. I'll show you data service. And actually, I'll show you the callout as well and where I found that example, because that one's not in the sample gallery. OK, there we go. Just gonna all right. So the sample gallery itself uses Salesforce DX. If you have not adopted the DX command line, and remember, DX is like a whole bunch of different things. All you really need is the command line to make this work. If you haven't done that yet, if you're more comfortable with a developer edition org, you can simply install the package for this same set of functionality, and then you can sort of pull that code down to a local project if you want to look at it. So you can kind of serve yourself either way. Now, if you saw the talks at the developer groups, I do want to start with a really basic example here of doing some binding and how that works. That is a little bit different from Lightning Aura components. So this is called hello binding, and simply, as I change some data, it's going to update the DOM based on the data change. OK, there it is. And the first thing that I'll show really quickly here, and I want to make sure I zoom in. So every component uses the HTML template tag as its root. So this is templating that's part of ECMAScript 6. And then you can see that we're using a Lightning card-based component, a Lightning input-based component. This one here, that's just on every component where we want to link to the code artifact in the GitHub repo, we just stick that component in there to do it. So you can kind of ignore that. And let's see. OK, so value has a binding to greeting, but onChange has a binding to handle change. And it's these two things together that make the DOM update happen. So if I go and show you the code behind this, or the JavaScript rather, it looks like this. So first of all, my greeting has this @track decorator. @track makes this a reactive property. You can also stick track on some other things. But when something is tracked, that means that as it's updated, the component will attempt to repaint its DOM. So default is world. I make a change to that. What's interesting is that greeting itself will do nothing unless I have the event handler. The event handler itself is what's actually setting the value from the input field into this .greeting, which of course is referring to that property right there. So one of the things that we found, one of our learning experiences around Aura components is that when you do two-way data binding and you allow those to be changed kind of anywhere in your application, state management becomes very, very tricky. And so this was actually one of the architectural decisions that was made around Lightning Web Components, which was to really just do one-way data binding. So as you paint the user interface, any data bound to that field or to that part of the UI will appear. If you want that to change, you have to go in and add the handler to change it yourself. So it does require a little bit of extra work, but what that means is you have a UI that's easier to reason about for the most part. OK, so there we go. So that's just a little bit on binding, which was one of the things I had to do. Now, what about invoking Apex? So here, and actually it's sort of helpful if you see the UI version of that. So here I'm going to go to this Apex wire method with parameters. Now there's two ways of invoking Apex. I'm going to show you an implicit invocation. In other words, kind of like what was happening with the track variable. So as things change, we can implicitly invoke some Apex code. So here, if I look for JO, I'll see some, and actually let me zoom in again, I'll see some matching results with JO. And so each time I'm making a change again, it's invoking that Apex code. So let's take a look at how that works. So first of all, there we go. There's my input, and there's my onChange handler. So handle key change is what's getting invoked. And then search key is just binding back to that search key, of course. But this is really the important thing, is that as handle key change happens, what's happening in my JavaScript code. And this is where it's really interesting. So first of all, the way that your Apex code is surfaced is actually done via an import of a JavaScript module. So we basically take anything that is at Aura enabled. We're still using the same annotation that worked in Lightning Aura components. And that gets surfaced as a module, which we can then import. And you can see that on line 2 up at the top, right? So I have this Apex class called contact controller that has a method called find contacts, and I'm going to import that as find contacts. And remember we saw the track, right? So that makes my property reactive. Wire connects that to a service that can go back, and as things change, it can invoke this Apex and set it into either a property, as is the case here, or a JavaScript function. Again, this is actually using a feature in ECMAScript 6 called a decorator. And I would encourage you to do a little reading on decorators. Decorators are basically a special way of invoking a function. And it's a way of kind of inheriting that function without implicitly having to subclass or put that on the prototype hierarchy for the class that you're creating. So that's what wire is doing. Find contacts gets invoked. And then search key, that's actually the name of the parameter in my Apex method. Now, the important thing is that when you're using wire, this $ search key is going to make the property reactive again. So as search key changes, and if you notice down here, handle key change, its main job is to make changes to search key, okay? So as search key changes, we're going to invoke find contacts. Now, there's a little bit of trickery going on here to make this asynchronous so that every single time a key is pressed, we're not going back to the Salesforce server. We're actually doing a set timeout, so that basically it will wait for a certain amount of time, and provided nothing has happened, it will then go and put this request on the event queue. However, the basics of this is as search key changes, right, we are going to be invoking this find contacts function, okay? The thing I like about this is that syntactically, it's super minimalist. There's very little to actually do to go and make a request to an Apex class. And even if I need to invoke it implicitly, I actually get to invoke that as a promise. I wasn't going to show that, but if we have time a little bit later toward the end, I can show an implicit invocation of Apex. Okay. So the next thing I needed to do was I need to be able to use the data service to update. Now, there isn't actually a recipe with update, but it is in the documentation. So I kind of, I got a taste for what the data service looked like by looking at this create record example. And that's right here under data service. And you can see here that, I can just create any account. So I could say London's calling and do create account. There we go, success, and then I get an ID back from that. So that's actually using it's actually using what's called a wire adapter that hooks into Lightning data service. So let's go take a look at that. So again, the markup is pretty straightforward. I've got some inputs. I have my button that I'm invoking, and my create account here. That's the thing that's actually going to invoke the logic. Looking at the JavaScript, what you're going to see anytime you're using the wire adapters for Lightning Data Service, you're going to see something like this. So Lightning/UI record API. Remember I said that wire adapters are accessing the user interface API? Well, again, that's what this is doing. And the interesting thing is you can actually go and look up how this works in the UI API developer's guide, right? So you can understand the underlying API. But you don't really need to know everything about that because, and actually I should zoom in again. There we go. All I need to know is how we surfaced it inside of the Lightning framework. So I'm going to have something called create record that eventually I'm going to invoke. And you can see down here that I'm invoking create record. And when I see a .then or a .catch or and a .catch, what does that mean? Any JavaScript developers out there? .then? Anyone? That's a promise, yeah. So we're using a promise. Now, earlier, if you were in Wes's talk, he talked about using async and await, which is a nice little syntactic sugar thing around promises. As of today, I've kind of made a choice that I'm avoiding async await because that has not been adapted and will never be adopted by IE 11. And so, when I think about developers that are out there in the wild, you may have some customers who are still on IE 11. Anyone have that? Yeah. And if that's the case, you want to avoid using features that aren't implemented in IE 11 because they will be less performant because you're going back to having a polyfill to make that work. So we'll polyfill it for you, right? If somebody happens to access your org using IE 11, it won't be the end of the world if you use it. But if you have a lot of users and you implement, if you implement a lot of async awaits in a bunch of components on users that are using IE 11, you may get some pushback on performance as a result of that, okay? Okay, so it's pretty straightforward because I basically construct an input that I pass in there as record input, and then I get the data back, right? So if the account was successfully created, I'll get back an account with an account ID, and then I can actually render that in the user interface. In fact, I don't have to explicitly render it because data service automatically sort of syncs that up. It just happens for me. And then, again, if there's a problem, I have a catch down here. And we're using show toast. So that actually also gets surfaced in an input. You can see right over here. We're importing Lightning Platform show toast event. And then that's how we actually use that in the context of Lightning Web Component. Okay, which I used as well. All right.
Sorry, Peter.
Yeah.
What's the handle name change? Why do you need that?
So what they're doing in this instance is when I go in and make a change to that, I'm essentially telling them I'm creating another record. So this is another record. And what that does is it clears out the ID so that when I do a create again, it doesn't fail. All right, cool. So a little bit about stitching components together. So far, I've kind of been showing a component here, a component there, sometimes using some base components. But obviously, you will probably create many of your own components, and you'll have to compose your own UI of some of your own Lightning Web components. So how do you do that? And to take a look at that, we'll take a look at this contact search here. And the search one is over here. There we go. And again, so if I type in JO, I get some results back from that, and I can see that just fine. However, in this instance, I have these cards being rendered. These are child components. You can kind of see very faintly, we're trying to call that out to you as you look at this, that that's actually a child component. So let's go take a look at that one. Zooming in, zooming out. Okay. So there's my search. There's, again, another handle key change. So that's going to look a lot like the one we saw earlier. Only now, what happens is, as we get back a list of contacts, we're going to be setting it into a contacts property. And then we are iterating using something called for each. So this is a lot like, I'm spacing on the Aura version of iteration. Anyone? Yeah, anyway, so there we go, contacts, for item, contact, and then you can see here, I'm setting contact and key. In order for these to be surfaced in the component when I use it, I need to tell the framework that I want to surface this property. So right now, all of the properties that you've seen in any of the JavaScript classes I've shown you have been private. We now have an example where we need to make one public. And the way we do that, oh, that's interesting. Thank you, yes. Tile, ta-da, there we go. The way we do that is we declare this as @API. So @API, and you can see that all we're doing is we're sort of popping a contact record into this. It's a super simple bit of JavaScript, but that's really all we need to store a contact record. And then all of the magic is done in this instance in the actual markup for that child component, okay? So when I set a value into API, right, then that's going to bubble down into that child record. And then there are things I can do that, in this case, I'm setting a property as API, but I can also surface a getter or a setter if I want to process that input as well. Now the contact search itself, like I said, is very similar to what we saw before, where handle key change is setting a value, and again, we're using set timeout to delay that, so we're not thrashing the Salesforce servers with lots and lots of Apex, or Apex requests. Okay. Now, in this instance, we're setting data into, from parent to child. We also might need to bubble data up from the child back to the parent, and this is where events come in. There we go. So here, this is called, this are examples of child to parent. And so, for example, here, my event with data, right? As I select any of these, it's going to take some data from the child. Again, you can see this is contact list item. It's going to fire an event that is then handled in the parent, okay? And where we go, with data. Yeah, that's it. Okay. Okay, so there's my C contact list item. It's very similar to the previous example where I set data into the contact property that's been surfaced as API. Now, the interesting thing here is that I don't know the implementation details of this component right now, but I am handling on select. So the handle select is here in the parent component. If I look at event with data, there's my handle select, and you can see I'm taking the event, I'm using some data from that event, and I'm setting it into this selected contact value, basically going in and finding that in a list of records that are stored in memory here. Okay? All right, so that's how it bubbles up, or how we handle it on this end. Let's see how we actually make it be emitted from the child record or from the child component. So this is the markup, and you can see that we simply have some bindings here, nothing too special. Although we do have a handle click on click. And the main part of this component is actually an anchor tag, right? So that means we have to make sure that we don't let the anchor tag perform some kind of default behavior. And here's how we do that. So on handle click, we take that event and we call prevent default. And this just ensures that we're not going to accidentally launch a new browser tab. We then take the contact ID. We set that into detail, which is what we saw when we were handling this in the parent. And then we dispatch select event. So this custom event API is not Salesforce's. This is the standard API for a custom event that is in every browser these days. Okay. The last thing I want to show, do I want to? Actually, I do want to show one last thing, which is how do you surface a getter and a setter? So maybe instead of just taking the data that was passed from the parent and just stuffing it into a property, maybe I need to massage that data somehow. How do I do that? And the way is actually to use JavaScript getters and setters. Again, this is pretty standard JavaScript syntax. I should say it's standard JavaScript functionality, really. And where are we? Right. And that's going to be in to-do list. There we go. So in this instance, instead of doing @API on a property, we have @API on the getter for to-dos. And the reason that we're doing that is actually by adding @API to either the getter or the setter, and as a best practice, pick one and go with it. We recommend the getter, but if you're doing it on the setter and you just always do it on the setter, that's fine too. So part of the reason we're doing this is that when we set the value in here, we're actually also calling this filter feature. So we're not just taking the to-dos, we're taking them and we are doing a filter function on those as we set those into this child component. And so that's another feature that can be very handy that I also found I needed to use as well. So I think that sort of sums up all of the pieces, except that I did want to show doing a call out. And the remarkable thing about this is actually how unremarkable this is, because fetch, again, is a standard JavaScript API. This allows me to do a request directly from the browser, and it's going to go to the URL that this particular example is using. This is like a stock quote, so go get me some information about a particular stock. And so we see a promise, right? So we get something back. We turn that into JSON, and then we process that in the next then, right? So we chain together a couple of promises, and then we pass that back to where we're using it. So that's kind of the interesting thing about this. What's cool about this is that this is also a Lightning Web Component, but it has no template. So the bare minimum for a Lightning Web Component is actually the JavaScript, not the markup. You need an XML file. You always need that. But the working pieces, right? Not the metadata. All right. So let's revisit this component that I wanted to build. Okay. Now we all saw the demo already, and I won't put you through that again. But this was the diagram that I showed you earlier. And as I started to go through these different recipes and learn more and more, and I built this incrementally. I didn't just do all the recipes and then build the component. I kind of did one thing at a time. Eventually, what I started finding is like, okay, I need an API here, right? And I'm going to need to use the @wire with an Apex to go and get my API key because I want to store it on the server. I don't want to store it on my client. And I'm going to need to make sure that I'm defining properties accordingly. I'm also going to need to use a custom event because when I get my list of addresses and I select that, I need to make sure to notify the parent that it's been selected. And I also want to use the wire adapter to do update record so that I can use Lightning Data Service and so that my UI will automatically refresh when my update occurs. Right? So all of those things are bits and pieces that I tried to show you in the recipes that eventually got incorporated into the end-to-end story with this component. So let's go back and take a look at that. Someday. There we go. OK. You saw the recording. I mean, I could do the end user demo again, but I think I'll jump right into the code if it's all the same to everybody. First off, I wanted to show the connector. So I'm actually using a web service called getaddress.io. It was a pretty easy, quick and dirty, temporarily free web service that served my purposes. And now that my key has expired, they still have some, so the John O'Groats postcode, that one is one that you can invoke with your expired, so I can still test it basically and show that it works. And you can see it looks remarkably like that connector component I showed you from the stock quote, where here, oops, wrong. So I've set my callout URI, and I'm doing the request to api.getaddress.io. There's my actual endpoint and resource with my API key appended on the end. Now, how do I make this work when Locker Service wants to say no? Is that I need to go into my CSP trusted sites in my org and whitelist this domain. And I can show that. If I have time, I will. But there are certain things that you can add to the CSP header that we will then allow you to do from your component. Pretty much the only thing that we don't allow you to do is to access a JavaScript library from a CDN. That's what we don't allow you to do. And I know that there are certain services, Google Maps, that require you to do that. The nice thing is we've implemented Google Maps now as a base component, so that solves that problem, at least for Google Maps. But that's really the only thing that we've kept that is completely blacklisted right now is anything that is going to a CDN for JavaScript. In any case, it's using a promise. There's my .then. I return some JSON. If that doesn't work, then I throw an error. Otherwise, I return my JSON back to my component. And let's go and see where I'm using that. So it's called address lookup callout LDS. By the way, I do have this repo in my own GitHub account, so you can take a look. There's a bunch of learning stuff in there as well that I should probably carve away and make it a bit more intuitive to find just this bit. So what are some of the things that I decided to do? I've got a postcode input. I've got my save and my find button. You can see here, this is a child component, see address lookup list, right? So in there, I have a handler. So I'm firing an event from the child. And in addition to that, when I get the result back, I set it into addresses. So that's going to update my DOM. So this tells me already there's a few things that I need to do in my component. So first of all, I want to use this in App Builder on a record page. I need to have my record ID surfaced as @API. The nice thing is that's all I have to do. I need to do nothing else, and I can use that record ID. The other thing is this result property needs to be tracked. So that @track reactive decorator, that needs to be on there because when I set it, I need to make sure to repaint this child component with this new data value, right? Anything else? I've got a couple of other handlers. So my onClick for find is called handle find, and my onClick for finally saving that back to Salesforce is called handle save. And that's kind of those are all the things that really we need to go over when we look at the code here. So let's take a look at that. There we go. So starting at the top, from LWC, I'm importing all the LWC stuff. So Lightning element is the subclass that I use in my module, or sorry, the superclass I use in my module. Track for reactive properties, API for surface properties, wire for invoking either Apex code or wire service adapters. My Apex is surfaced here, right? So again, I'm importing it as get API key. And then my connector component is also being imported as a module by its component name. So C/ and then component name. Let's just cover off the Apex first, because I mentioned I had that. But really all I'm doing is going to a custom setting and retrieving my API key. Just check my time. Oh, good. Got about 5 minutes. That should be perfect. Okay. So that is here. And this is one of my favorite lines of code in this whole solution. That's all I have to do to invoke an Apex method and get the data into my Lightning Web Component. I love that. One line of code. Okay? All right. Now, in addition to that, I mentioned using this in my record homepage. In order to read the record from that particular, whichever record I'm looking at, I need to use @API on record ID. But the nice thing is that's all I have to do, quite literally. If I'm going to use something like the Lightning detail or Lightning edit, I also need to, there's another property I need to surface as @API for the SObject type. But if that's all I need is an input form that's based on an existing page layout that needs to be surfaced in my Lightning Web Component, I just need 2 properties in my JavaScript, and that's it, and it works. In my case, I'm not doing that, but I still need the record ID so I can do the update, although that's pretty cool too, how that works. The 2 really critical @track properties are result. Remember, that's the one I'm going to set the value, and it's going to populate the child. I also need to make sure error occurs, because you might have looked at this line here. Anyone look at this line and think, how do I handle the error there, Peter? Anyone think that? Yeah, good job. Actually, this is how I do it, is I have a tracked error variable, and that's the expected API. When you use wire, if an error occurs, it will hydrate error with the error, and then you can surface some user interface that says something went wrong. Okay? All right, what else? Okay, so handle find is here. It's where the first bit of rubber meets the road. I'll just focus on the key bits. So find addresses from Postcode, that's the utility or the service component that I showed you a little bit earlier. I'm actually in the process of re-implementing this as a class as opposed to a module with a single function, but that's still kind of in flight. And then I get my response back. I set it into address list based on some manipulation of that using array.map. And then the really important thing, remember, is that I need to set the result property so that I can populate my child list of addresses. And that happens on this line right there. This.result equals address list. That's where I take that process address list, set it into the result, and it's at that moment in time the DOM repaints and I see the related, or the retrieved addresses for that postcode. Okay? So that is the process of making the call out. Once I have that, let's take a look at what address list looks like. And that's here. So remember I said I needed to make sure that I was, oh, there we go. I needed to have a getter and a setter for addresses. And the reason for that is that whatever I pass in, this particular component is using Lightning radio button. And Lightning radio button expects a particular data structure in its radio list. So what I'm doing is in my setter, again, I'm using array.map to take the raw array value and then transform it into a data structure that works for Lightning radio button. Okay? Or maybe it's the radio list. What is it? Radio group. There we go, Lightning Radio Group. And so that's basically here, addresses are my options. When I select one, that's going to set value. And then when it changes, I have handle radio change. So those two things are critical because that's what I'm going to do to actually broadcast this up to the parent. So handle radio changes here. Again, I have a prevent default. I have my custom event, again, standard JavaScript custom event, set into change event. I take the value, set it into detail, and then I dispatch the event. Now, in the parent, so back here on address lookup callout LDS, there's my handle address change. So I'm taking event.detail and setting it into selected address, and now I'm ready to save. All right, so last little bit is I'm going to use the wire adapter of update record to perform my update. Now, I said the Apex line of code was my favorite one. This is my second favorite discovery. Who here writes code for an ISV? Okay. So one of the things as an ISV is you want to create components that are as universal or reusable as possible, right? And if you can avoid explicitly stating an S-object type, that automatically makes your code more reusable, doesn't it? So when I construct the object to update, you can take a look at it here, right? So update object.fields. What's missing from the definition of that object? What's that? The S-object type. Why is that? Well, I don't know this for sure. I didn't ask anybody, but my inference is that it's because we can infer it from the record ID, can't we? Right? If it's 003, it's going to be a contact. 001, it's going to be an account. So what's cool is when I go and do my updates using the wire adapter, which is the UI API again, I can just put the fields on there that I want to update, put the ID, send it to Salesforce, and it will take care of making sure that it saves to the right S object, which I think is cool. All right, update record, again, we have a promise. If everything goes well, we show toast and it's happy. If everything goes poorly, we show toast and it's sad. And that pretty much sums up my component. So let's wrap up here. Okay, who liked what they saw today? Anyone? It's almost everybody. A few little shy British, half-raised hands, but I'll take that as a victory. By the way, I say that as a Brit. I actually am a British myself, naturalized, but who here feels like, God, I can kind of do JavaScript code, but I don't really know what I'm doing? Go to this trail. When we knew Lightning Web Components was on the horizon, I sat down with one of the content developers for Trailhead, and we cooked up what would a JavaScript trail look like for Salesforce developers? This is it, and I recommend it highly. Peter, do you recommend it? There we go. See, don't trust this Peter, trust that Peter. If you feel pretty solid with your JavaScript, but you want to dive deep into Lightning Web Components, do this trail. That is the trail for everything all-inclusive Lightning Web Components. Jody is telling me I have to stop. There's a slide with some core JavaScript skills that I think that everybody should know if you're starting to write JavaScript in earnest. Take a quick picture. I give you 2 seconds. 1001, 1002. Oh, okay. And thank you very much, everybody.